Hi there! After this lesson, you should be able to graph a linear equation on the coordinate plane. Carrie decides to start selling friendship bracelets for $2 each to family and friends so she can save up to buy a scooter. Carrie must first spend $6 to buy several colors of string. Here is the equation that represents the profit Carrie will make after selling X amount of bracelets. Let's see if we can create a graph to represent the profit Carrie will make. Look at the equation. It is in slope-intercept form, where m is the slope and b is the y-intercept. In this instance, the slope is 2 and the y-intercept is -6. So right away, I know that the line is going to pass through the y-axis at -6. This is the point 0, -6, and this is my first point. The slope will give me directions to my next point. But how does slope give directions, you might ask? Well, one of our definitions for slope is rise over run. Think of a sunrise. What direction does the sun go? Up. The rise tells us the vertical direction, how far up or down to travel from one point to another. And if I told you there was a giant mouse behind you, you would probably run in a horizontal direction. As such, the run tells us how far left or right to move. So let's take a look back. It is helpful to write slope as a fraction so we can see both rise and run. We can write the number 2 as 2 over 1 to see that we must rise 2 units and run 1 unit. Let's zoom into our graph a bit. All right, we will rise 2 units and run 1 unit. So you can see that I rose 2 units and I ran 1 unit. This is the location of my second point, 1, -4. I can now draw a line through these 2 points, and there we have it, the graph of the equation y equals 2x minus 6. Let's take a look at a second example. Let's graph the equation 5x plus y equal to 7. At first glance, you might be confused. Where's the slope? Where's the y-intercept? A large part of algebra is manipulation of numbers. We can rewrite this equation so that it is in slope-intercept form. I know slope-intercept form is the form y equal to mx plus b. So let's simply move that 5x over by subtracting it from both sides. Good. My new and improved equation is y equals -5x plus 7. I see the y-intercept is 7, so the first point on my graph will be 0, 7, right over here. The slope of the line is -5. We can write this as -5 over 1. Now we have directions to our next point. First, I will rise -5. Your first thought might be to go up 5 units, but since this is a negative number, we will do the opposite and go down 5 units. 1, 2, 3, 4, 5. Next, we will run 1 unit, or go to the right 1 unit, just like so. If this number would have been negative, we would have moved to the left. Okay, so now we have a second point, 1, 2. We can draw a line through the points to make the graph of the equation 5x plus y equal to 7. Your turn. See if you can graph the equation y equal to 3/2 x minus 1. All right, let's take a look. The y-intercept is -1. Remember to take the sign with it. So I know my first point is at the point 0, -1, or right here on the y-axis. The slope is 3/2. Remember, slope is rise over run, so we will rise 3 units and run 2 units. They are both positive, so we will go up and to the right. Here we go. Rise 3 and run 2. And here's a point. Rise 3, run 2, and here's another point. Okay, that's good. You only need 2 points to make a line, but sometimes I like to do this multiple times so that I can easily draw a straight line through them. And here we have the graph of the equation y equals 3/2 x minus 1. Now for our final example. What happens when you have an equation such as y equal to 5? You will notice there is no slope. If we were to write this in slope-intercept form, it would look like y equals 0x plus 5. As before, we can plot the y-intercept at 0, 5 right over here. However, since there is no slope, we have to think about where to put the next point. Well, the equation tells us that y is equal to 5. This means that for any value of x, y will always be equal to 5. So, when x equals 1, y equals 5. When x equals 2, y equals 5. And when x is equal to 3, you guessed it, y is equal to 5. And you get the drift. This will continue for any value of x, thus giving us a horizontal line. Along the same sort of thinking, when we have x equal to a number, say 9, then for any value of y, x will be equal to 9. In this instance, we see that a vertical line will appear. Now you try it. See if you can graph the equations y equal to 4 and x equal to negative 2. Alright, for the first equation, y is equal to 4. This means that for any value of x, y will equal 4, and so we get a horizontal line that passes through 4 on the y-axis. The equation x equals negative 2 gives us a vertical line that passes through x at the negative 2 point. Good. Alright, we did a few examples together, but let's summarize how to graph a linear equation. See if you can fill in the blanks as we go. First, to graph a linear equation, we must first identify the slope and the y-intercept. We can start by graphing the y-intercept. The slope gives us direction from there as follows. The rise, it tells us how many units up or down to go. The run, it tells us how many units left or right to move. Lastly, the graph of an equation y equals to some constant is a horizontal line. The graph of the equation x equal to some constant is a vertical line. Great job!